name is Evan Walters, and I am the Regional Market Segment Manager for Biotage. And today I will be presenting to you some studies done in which we were able to compare different QueChERS cleanup techniques for analysis of pesticides by GCMS. So a quick outline of what I'll be presenting today. I will briefly be going over what laboratories are thinking about and considering when testing for organic compounds in food and agricultural matrices. I will then jump right into comparing DSPE or dispersive SPE to automated CSPE or column-based SPE cleanups. And then we'll finish it off with some conclusions based on some of the data that we were able to produce with this study. So when considering different testing application areas for food and agricultural testing, there's really 4 areas that come to mind, and that's food authenticity, food safety, nutrition, processing, and packaging. Within these are different subcategories, and for today's focus, we'll be looking at pesticides, which typically fall within the food safety and agricultural safety realm. So to understand the importance of pesticide testing in food and agricultural safety, really, I think it's useful to consider the analytical goals of the laboratory in which the testing is being performed. And typically, I like to think of 3 different areas in which are considered during the development of a testing protocol. And that is, do I have enough sensitivity? Is my extraction technique good enough? And how complex are the matrices in which I'll be analyzing? And in the middle of that, you have operational efficiency considerations. And when they all tie together, you have a very, very nice procedure that is efficient and gives you the proper sensitivity for your matrices. Now, a lot of the times when our matrix complexity increases, our analytical sensitivity for that matrix decreases, just due to the exogenous material that are present within the matrix. So to improve that, the extraction technique must improve in order to remove some of the interferences in exogenous materials. This is why understanding your matrix complexity and your extraction technique and how that relates to your analytical sensitivity is very important, and it is an important analytical goal for laboratories to consider. Now, I find the simplest way to think about sample matrices is to at least start by dividing them into 2 types of matrices, solid matrices and liquid matrices. And for organic testing labs, the goal is to get the analytes of interest into the liquid form for further analysis and quantification. Now, sometimes that requires multiple pre-treatment steps and even cleanup steps. And typically this is done by a process known as QueChERS. And QueChERS is an acronym that stands for quick, easy, cheap, effective, rugged, and safe. Now, although they may be 2 different matrices, solids and liquids, the goal and the process all ends up into the same cleanup, which is a QueChERS-based cleanup. This is the main topic of this presentation today. Now, whether you started with a solid or liquid sample matrix, once you've extracted your analytes of interest into a liquid form, it is time to move on to the next stage, which is a QueChERS cleanup. And this is typically done by SPE, or solid phase extraction. And now the goal of this is to remove any interference compounds or material from your extract, leaving only the analyte of interest in the final extract. And there's really 3 ways of potentially doing this. And one of the most popular ways is known as DSPE, or dispersive SPE. And this is where the analyte is not retained on the SPE media, the matrix components are retained. But there's also 2 other ways that you can do this. There is pass-through column SPE or retention elute column SPE. Pass-through works very similar to dispersive SPE, and whereas the matrix components or the interferences are retained on the media and the extract with the analytes of interest are passed through the media into an elution and collection vial. Now for retention and elute, this is slightly different. The media actually retains the analytes of interest. The interference compounds are washed off the media, and then the analytes of interest are eluted and collected. Now for this study, we compared pass-through column SPE to the traditional DSPE or dispersive SPE, since they were both using the similar QueChERS retention mechanisms. So what exactly is a QueChERS cleanup? Well, traditionally speaking, QueChERS cleanup uses DSPE, or dispersive solid phase extraction. But as we just found out, you can also do the same retention mechanisms using pass-through or column-based SPE. So here is where we evaluate the 2 options, QueChERS DSPE versus QueChERS CSPE, to see if they both meet the QueChERS criteria of being quick, easy, cheap, effective, rugged, and safe. So for our first comparison, we evaluated whether either format met the criteria of being quick and easy. And the way this was done was doing a timing comparison for the steps involved to carry out a DSPE versus a CSPE cleanup. And as you can see, each step has its own timing associated with the format being used. And overall, we found that there were some time savings using column-based SPE, especially due to the fact that on the platform being used, being the Extrahera HV5000 automated platform, you're able to run up to 48 samples in a single run, which allows you to be as quick and as easy as the traditional dispersive DSPE cleanup. So for both options, we felt that they met the QueChERS criteria for being quick and easy. Now the third criteria in which we evaluated for QueChERS cleanup was the cost associated with the cleanup sorbent. And as you can see, traditional DSPE sorbents in the market, you have the extraction salts and the SPE cleanup. Now, for all techniques, the extraction salts stay the same, so we kept that value the same. But you'll note that the SPE cleanup associated for each sample, for column-based SPE, the cost decreases as you decrease the size of the column. And we found that compared to typical pricing for DSPE cleanups, 3 ml column-based SPE cartridges were roughly equivalent to what it would cost for a dispersive SPE cleanup. This is also corresponding to the Extrahera HV5000 format, in which 48 samples can be processed in a single batch, which also is beneficial for the throughput in which these samples can be processed. So all this data was produced on 3 mil column SPE and compared to traditional dispersive SPE cleanup formats. Now, the next parameter that we compared for DSPE versus CSPE cleanups was the effective parameter in the QueChERS criteria. And the best way we found to do this was taking a look at the recovery comparison for roughly 50 pesticide compounds spiked into spinach extracts. And as you can see, we have 50 pesticide compounds listed on this chart, and the average percent recoveries for 3 replicate spike samples for each format. Now, it's kind of hard to tell from this chart how well the 2 formats performed, but as you'll see in the next slide, once you bucket the data, you can get a better indication of the effectiveness for each format. Now, we found that placing the data into buckets helps give it a clearer picture of how effective each cleanup format was when comparing to the next. And as you can see in this bucketed data, the number of analytes that were within the range of 100 to 130% are listed for both formats, 70 to 100% for both formats, less than 70%, and 0%. And bucketing the data in this way shows you a few major points. One being recoveries for both formats did not exceed 130%. The majority of the column-based recovery were between 100 and 130%. The majority of the dispersive SPE recoveries were from 70 to 130%. And DSPE was the only format that produced results with 0% recovery for 2 analytes. We found that this demonstrated that column-based SPE or CSPE can provide acceptable recoveries when compared to DSPE cleanups. Now, the next criteria in which we evaluated for QueChERS cleanups was whether or not the cleanup technique was rugged. And this for us meant, can it be reproducible for sample to sample analysis? And from the spinach extract that were spiked with the 50 analytes, we were able to produce RSD or relative standard deviations for each recovery. And as you'll note, anything that was not recovered were plotted as 100% RSD, since there's no way to plot the RSD if there was no recoveries for that analyte. But again, we find it much more useful to bucket the data for a better comparison of how reproducible each cleanup technique was. Now, taking the reproducibility data from the previous slide and placing it into buckets for each cleanup technique, you're able to paint a clearer picture of the performance between the 2 techniques. And as you can see again on the x-axis, this is the number of pesticide analytes that fell within that bucket. And on the y-axis, you have the percent relative standard deviation. And so the best RSD would be less than 5%. And you'll note that DSPE or dispersive SPE did not produce any results for any target analytes less than 5% RSD. And CSPE was the only technique that did that. You'll also note that the majority of the CSPE RSD results were less than 10%, whereas for the DSPE or the dispersive SPE, those were mostly falling over the 20% RSD line. We found that after evaluating the data in this way, column-based SPE or CSPE provided superior reproducibility when compared to the traditional dispersive SPE. So we thought that maybe traditional DSPE didn't really quite meet the criteria for rugged. So in conclusion, we found that although dispersive SPE is often associated as the only option for a QueChERS cleanup technique, this is not the case, and column-based SPE can also meet the QueChERS criteria and give acceptable results. We also demonstrated that automating the column-based SPE on the Extrahera HB5000 met all the criteria of the traditional QueChERS cleanup technique. One thing we found that was interesting was that the CSPE QueChERS provided superior data reproducibility when compared to the dispersive QueChERS cleanup technique. This left us to conclude that automated column-based SPE is an attractive option for QueChERS-based cleanups when compared to traditional DSPE or dispersive SPE cleanup techniques.